Greetings. In graph theory, we have something called subgraphs, and in this one, we'll be talking about something called induced subgraphs. So, an induced subgraph is a particular type of a subgraph, where subgraph is when you have a graph with a vertex set and an edge set. Then a subgraph is basically another graph that its vertex set and its edge set is the subset of that vertex set of the previous one, and with that edge set is the subset of the edge set of the previous one. So that's that. And now let's see an example of what an induced subgraph is, and also the notation. So let's say our G will be this C4, which is 1, 1, 1, 1. So 4 edges and 4 vertices will be this C4, and I will also name those edges. So 1, 2, 3, 4 are the names of the edges of the vertices. Now the edges will be called after the vertices, which are connected by them. So this is 1, 2, this is H1, 2, 2, 3, and so on. So this G, this C4, I can also specify it in terms of V and E, the vertices set and the edge set of it, where the vertices set is the 1, 2, 3, 4, edge set will be the connections, the 1, 2, 2, 3, 3, 4, 4, 1. And now, this is a simple graph, and let's see an example of an induced subgraph. So a subgraph generally is another graph, the vertex set of which is a subset of the vertex set of the G, of the original one. The same goes for the edge set. And an induced one is basically one pins out the vertices one wants to have in that subgraph, and then also adds all the edges that are between those vertices, between any of those pairs of vertices within those chosen ones. So for example, if I say that I want an induced subgraph, I specify a particular subset of the original vertex set of the original graph, and from that everything will be based and derivative. So let's see. So let's say that my set through which I want to induce a subgraph on G, on this graph G, on this C4, will contain 1 and 2, and let's say also 3. So what then I will do is basically look at that original graph and see, well, so these 3 vertices I will definitely have in this subgraph. And now, induced, what it says is any of the edges connecting these chosen vertices, we must have them in that induced subgraph. So we'll also automatically add all the edges that were between these vertices in that original graph. So that means that the induced subgraph, induced by S on G, so is denoted like this, G, and then these brackets, and the set which induces it, which here is these 3, will basically be looking like this. So we have 1, 2, 3. The 3 vertices 1, 2, 3 are chosen, and then we take all the edges that connect them. Now this is C4, and let's say we don't have a C4. Let's say we have it's not a C4, but this is G, and now I slightly change it so that we just practice the same idea. I say here are these connections. Let's say even here is a connection like this. So now what will we have to take into account? Well, there's now more edges. So now if I want to induce a subgraph from the set 1, 2, 3, I will again take these 3 vertices. So definitely my induced subgraph, if my set from which I induce it is 1, 2, 3, by which I induce it is the 1, 2, 3, I know that from the original graph I must take the 1, 2, 3 vertices, these 3 ones, and I must also take all the edges that were between them anyhow. So 1, 2, 3, and now we not only have the 1, 2, and 2, 3 edge, but we also have the 1, 3 edge. So if I change this original one like this, and I want to do this induced one by S, again on this G, now because I changed the original one, here you see. So that example before was simpler, but now we see we can have more edges, and not just a simple cycle graph, but even something like this, and then we also have to add all those edges. So any of those edges that were between those chosen vertices must be contained in this induced subgraph. So that's the idea. Let's take one more example. Basically, this GS will be, if I want to again sort of define it, or at least make it similar to how we wrote down the G. It had the V and E, it had the vertex set and edge set. So the vertex set will now be S, and the edge set will be edges that connect anything within the S. Okay, let's in a word manner, simpler to see now, alright, faster. So this is our induced subgraph, and it can be defined via words, and like this. We only take the vertices from the predefined set S. Here I chose these three to be in S. I could also just say 1, 2. And then the edges that will have to be in that induced subgraph are all the ones that are between these chosen vertices. One more example. Let's say we have a complete graph like this. So let's take a complete graph on 5 vertices. So we have this. 1, 2, 3, 4, 5. Now let's make sure that everything is connected. Alright. Now this seems like we have a complete graph, K5. And here induced subgraphs are also very interesting, because now again I can name the vertices. So 1, 2, 3, 4, 5. And now let's say I want 2, 3, 5 as my S. So 2, 3, 5 is my S, so that's my inducing set, and I want to induce, right, K5, and via the S here is not the same S like here, right, so let's separate it. We're talking about different S here. Now here on the left, now what will that be? Well, this is the S, and I chose here 2, 3, 5, so definitely we'll have these 3 vertices in the new graph. So we can draw it, even with the same orientation. So 2, 3, 5, we have the same ones. And now let's take all the edges between them. So 2, 3, 5, we have 2, 2, 3, 2, 5. And now we have just 3, and it's a complete graph, so actually there will be no more than that. Alright, so here there will be no more than that. But if we actually, for example, chose also 1, let's say it also contains 1. So 1, 2, 3, 1, 2, 3, 5. Then I'll add also the 1. And now we also have to add all the edges to the other vertices that exist in the original graph, because we have this vertex 1 there as well. So to 5, to 3, to 2. All these 3 are in the original graph as edges between the chosen vertices in that S. So this is the induced subgraph with the set 2, 3, 5, 1 from the complete graph K5.